Hey everyone, and welcome. Today we're going to be detectives. We're opening up a cold case file on something you've probably seen a million times, the forehead wrinkle. But we're not investigating who has them, we're doing a full forensic investigation into how they're actually made.
So, what is the real story here? We usually just chalk up wrinkles to getting older. But what if I told you that to scientists, a wrinkle is actually a mechanical failure? Yeah, really. It's a puzzle of physics and force that they're determined to solve. And that kind of gets us to the heart of this whole mystery. See, a wrinkle isn't just a surface level thing. It's the end result of a physical process. Think about it like a piece of metal buckling under pressure or a sheet of paper getting a permanent crease. It's a mechanical event, and that's exactly how researchers are looking at it now.
Now, you might be wondering why this gets so much scientific attention. Well, here's why. The anti-aging industry is absolutely massive. We're talking over $66 billion. That huge economic interest, it's what fuels the kind of high-tech research we're about to get into. Understanding the mechanics is everything.
And this quote from the researchers really just hits the nail on the head. To crack this case, we have to start thinking like engineers. The real key, the secret sauce, is understanding the mechanics of how our skin folds and buckles when it's put under stress.
So, every good investigation starts at the scene of the crime, right? Well, for us, that's the skin itself. But before we can figure out what causes the wrinkle, we first have to understand the incredibly complex place where it all goes down. You see, our skin is so much more than just a single sheet. It's this high-tech, living, breathing material made up of 6 totally distinct layers all working together. Think of it less like a piece of paper and more like a complex living sandwich, where every single layer has its own unique job.
Okay, so let's peel back these layers. From the very top, the part facing the world, you've got the stratum corneum. That's the main protector. Right under that is the viable epidermis, which is like a living shield. Then you've got this crucial anchor, the dermal-epidermal junction, holding the top to the bottom. Deeper still is the papillary dermis, a sort of soft cushion. Then the reticular dermis, which is the tough structural core of the whole thing. And finally, way down at the bottom is the hypodermis, the deep foundation. All 6 are players in this story.
All right, now that we've thoroughly examined the crime scene, it's time to line up our prime suspects. We need to figure out what forces and what factors are actually responsible for creating these folds in our intricate 6-layered skin. So the investigators have flagged 2 main types of wrinkles we need to consider. First, you've got your dynamic wrinkles. These are the expression lines you see when you smile or raise your eyebrows. They show up, and then they disappear when your face relaxes. Then you've got the static wrinkles. These are the ones that stick around, the permanent lines that are there even when your face is totally still. Any good theory has to explain both.
So how do you put these suspects on trial? Well, you build a virtual crash test dummy for skin. Scientists created this incredibly sophisticated 6-layer computer model that perfectly mimics the forehead. This let them run all sorts of experiments and test different theories in ways you just could never do on a real person. And here we go, our first major piece of evidence from the simulation. When the model applied the exact same amount of muscle force, the virtual aged skin, well, it formed wrinkles that were way, way deeper than the young skin. So this confirms it. Age makes our skin much more vulnerable to the same exact forces.
Now get this. This next clue is a big one, hydration. The simulation showed that even on young skin, just letting that outer layer get dry caused wrinkles to become almost 38% deeper from the same muscle movement. This is the science behind why moisturizers work. A hydrated outer layer is just more flexible, it's better at resisting that buckling force. Okay, so with all this evidence on the table, the virtual experiment is ready to deliver its final verdict. We can finally put our main suspects head to head and see who the real culprit is behind those deep, permanent forehead wrinkles. So this is it, the final showdown. What's the main driver? Is it the loss of volume and the thinning of the skin that just happens over time? Or is it the constant compression from our facial muscles year after year? Well, the simulation gives us the cold, hard data. First up, age-related tissue loss. So if you only factor in the skin getting thinner and losing some of its plumpness, the model says you get a wrinkle that's about 163 micrometers deep. Okay, so it's definitely a factor, it's on the board. But now, look at this. When the simulation only looks at the force from muscle contraction, the wrinkle it creates is 269 micrometers deep. The numbers just don't lie. That squeezing force from our muscles is by far the more powerful wrinkle maker.
So the verdict is in. Case closed. While aging and losing tissue definitely plays a role, it's kind of like an accomplice that weakens the skin's defenses. The primary force, the main culprit sculpting those deep wrinkles, is the repeated mechanical compression from our facial muscles. Our expressions literally shape our skin over a lifetime.
And this all explains so perfectly why common treatments work the way they do. Keeping your skin hydrated makes that outer layer more resilient. And it confirms that our expressions are the biggest driver. That's why Botox, which reduces muscle contraction, is so effective at preventing that buckling. And it's why fillers, which tackle the accomplice of tissue loss, also work. They're both just engineering solutions to a mechanical problem.
And that kind of leaves us with this one last really fascinating thought. If a wrinkle is, at its core, a problem of material science, a mechanical failure, does that mean that someday we won't just treat it, but we could actually engineer the problem right out of existence? Pretty wild. Thanks for joining this deep dive.